Hello students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the 9th lecture on this alcohol, phenol and ether chapter. In this lecture we are going to discuss a very important thing, that is the physical and chemical properties of the ether. So heading of today's lecture is today in the 9th lecture we are going to discuss the physical and chemical properties of ether. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. When we are talking about the physical properties of the ether, what comes to our mind, that is the physical state. Diethyl ether or ethyl methyl ether, all are in gaseous state at room temperature. When the molecular mass of the ether is increasing, its physical state also going to be changes and it exists as a liquid. Second thing that is again very important in regard to the physical property, that is the dipole moment. So first thing that we have discussed, physical state. Physical state means it exists as a gaseous state or in the liquid state depending on its molecular mass. Second thing, that is the dipole moment. As like your H2O, the oxygen atom is sp3 hybridized, and that is why there is the molecule have the bent structure and there is a polarity in the CO bond. Although this polarity is not so much as we compare with the polarity of the CO bond in alcohol or in the aldehyde. Its dipole moment of this CO bond in ether is around 1.15 dBi to 1.3 dBi. In alcohol, it is 1.7 dBi to 1.8 dBi. And in aldehyde and ketone, aldehyde or ketone, it is around 2.3 to 2.8 dBi. Third thing, that is a very important thing in regard to the physical property, that is the boiling point. Boiling point is very less if we compare with the alcohol, and that is due to this fact that it do not form hydrogen bonds with the molecules themselves. That absence, due to the absence, we can write the absence of hydrogen bonding. Absence of hydrogen bonding in between the molecule, as against the alcohol. That is where talking about the alcohol. If we compare the boiling points with the alcohol, that is butanol. Butan-1-ol, it is boiling point is 390 Kelvin, whereas in case of ethoxyethane, that is C2H5OH, its boiling point is only 309 Kelvin, and that is due to the absence of hydrogen bonding. Fourth point, that is the solubility. Solubility, you can see, it is a comparable as we compare with the alcohol. For alcohol, as for example, if we take the butanol, its solubility is around 9 gram per 100 cc, whereas in case of ethoxyethane, its solubility is around 7.5 gram per 100 milliliter, and that is due to this fact it's form a hydrogen bonding with the water. Solubility is comparable with the alcohol because forms, we can write, forms hydrogen bonding with water, and that is the reason it has a good solubility. But as the molecular mass of this ether goes on increasing due to the increase of the non-polar hydrocarbon part, its solubility goes on decreasing. That what we have observed in case of alcohol also. So these are basically the physical properties. Now we are going to discuss, that is a physical property. Now we are going to discuss the chemical property. In chemical property, the first point that we are going to discuss, that is it acts as a Lewis base. It acts as a Lewis base because the oxygen atom having the two lone pairs, and these lone pairs can be donated to any other acid, and it has been observed that it has dissolved in any type of acid, in HCl or H2O, so forth. So it will going to form, if we take, this is the ether, and with HCl it is going to form this product. This is called oxonium salt. This is called oxonium salt. Again, with the Lewis acid like BF3, AlCl3, or we can say that is a Grignard reagent, it will going to form a product, coordination compound. That coordination compound that we can learn in the class 12, that is a special chapter for this, and it will form a coordination compound with those Lewis acid, because Lewis acid having the deficiency of the electrons. So it will going to form, and this is called the etherates. As for example, R2O plus BF3. BF3 is a Lewis acid, and it will form this. There will be a coordination compound. The electron pairs will be donated to the BF3, and it will form etherates. Again, this another reaction for this, that is RMGX. RMGX, that is the Grignard reagent that you can see. So this is formed the etherates, and that is why the Grignard reagent, when it is being produced, it will be dissolved in ethers. the ether, it will make a coordination complex. Now, second reaction, this is an important reaction that we are going to discuss, that is the reaction with halogen acid. First, let us discuss with the reaction with PCl5. Reaction with PCl5, phosphorus pentachloride. So, you can write reaction with PCl5 here reaction you can see PCl5 plus we are taking diethyl ether, and when it is heated it will produce ethyl chloride and POCl3. Third point, the reaction with sulfuric acid H2SO4. In dilute acid, it will form a different product, and in presence of concentrated H2SO4, it will form a different product. Dilute acid, it will form plus H2O, because it is a dilute acid, so it will react with H2O and it is going to form the alcohol here. Okay, now with second thing, that is concentrated acid, concentrated H2SO4. It will form RO plus H2SO4, and it is going to form alcohol, and another product it is going to form, that is here alcohol is produced and another product is produced, that is alkyl hydrogen sulfate. Alkyl hydrogen sulfate. Okay. Now another reaction, because the 4 number reaction, that is the reaction with acid chloride, and acid anhydride, we are taking diethyl ether plus CH3COCl in presence of anhydrous ZnCl2, and it will going to produce C2H5Cl and CH3COOC2H5. When we react with this acid anhydride, in presence of anhydrous LCl3, it will going to produce 2 molecules of CH3COOC2H5. Fifth reaction, that is a very important reaction, the reaction with halogen acid. Reaction with halogen acid, that is HX, where X is chlorine, bromine and iodine. the CO bond is not very much active, or we can say it is very much strong. So we require some very drastic condition to break it. So the general reaction, that is, this is a ether. When we react with this halogen acid and it is around 373 Kelvin temperature, at this temperature it is going to produce alcohol and alkyl halide. Alcohol and alkyl halide. When there is a excess of HX, that is the halogen acid, this ROH has been converted into the RX, that is the alkyl halide. So we can write this reaction in this fashion: plus HX, it will going to produce the RX plus H2O. In excess, we write in excess halogen acid, it will going to produce. For the cyclic esters like tetrahydrofurans, the reaction will be this. Tetrahydrofurans, the reaction will be like this. With suppose HI we have taken, then it will going to, suppose we have taken HBr, suppose HBr we have taken, so it will going to produce CH2 and there will be a bromine. So it is 1,4-dibromo, 1,4-dibromo butane with halogen, with HBr, you can going to produce. It is the tetrahydrofuran, cyclic ester. Okay. Now this halogen acid, there is a very interesting thing. Let us understand for this halogen acid. First thing, suppose we have taken this CH3O CH2CH3, that is ethyl methyl ether. At that time, when we react with this HI, suppose we react with halogen acid, that is HI we have taken, so it is going to produce this alkyl halide and alcohol. And this reaction is going on as per SN2 mechanism. As for example, this reaction, suppose you are taking that another ether, when this has been reacted, here also the reaction which goes on in the SN2 mechanism, and here this bond, this CO bond will be breaks. So it is going to produce this alkyl halide and this alcohol. Also butyl alcohol, it will produce an alkyl halide. Now question arises, if we take this ether, what is this ether? This is the tertiary butyl ethyl ether. When we react with this HI, at that time, what will be the product? The product will be slightly different from this, because in this case, the reaction mechanism is SN1 and this reaction product is determined by the production of the carbocation. Here this carbocation, this carbocation, when this will reacted with HI, what is going to happen? First it will be protonated. So this H plus ion will be attacked there, and you will find this. This will be protonated. When this is protonated, at that time there is a two option. This CO bond will break or this CO bond will break. But this CO bond will break because this will give the stable carbocation. Stable carbocation this is a stable carbocation in the sense because this H plus ion that is developed in the carbon atom has been stabilized by this CH3 group. This is the electron releasing group and it will stabilize it. So it is a very stable stable carbocation. So this will form, and along this will form. So after that, the nucleophile I minus as is iodine minus iodide ion will be attached to this, and this is going to be prepared this tertiary halide, tertiary iodide, tertiary butyl iodide will be produced, and along this ethyl alcohol will be produced. So the nature of the product from this ether, that is also depend on the which type of ether we are dealing with. If it is a tertiary, one group is a tertiary, that's in this case it is a tertiary butyl, there will be formation of this, that is tertiary halides will tertiary iodide, tertiary butyl iodide will form with this alcohol. So this type of product that is observed, that is a very important thing. Questions, different type of questions will ask in this regard. Suppose you have been given these choices that this is the reaction, then what product will be formed. At that time you have to take care which type of carbocation is going to be produced and whether this carbocation is stable or not. That we have observed here also. Okay, and this is the mechanism due to the difference of the mechanism, because in this case the mechanism is SN1, in this case the mechanism is SN2. That is why there is a difference in the product. Okay, now we will be going to discuss if there is a phenolic ether, at that time which type of product will be produced. C6H5O CH3. This is called the anisole. So what will be the reaction product? In this type, the reaction product will be always, that is methyl iodide plus alcohol. Always it will be going to produce this, because this CO bond is much more stronger. The oxygen, the bond with the benzene ring, is much more stronger due to the present double bond character has been imparted in this bond, whereas this bond is a weak bond. So every time we will find this product. Okay, so for phenolic you can see it should be phenol and the other alkyl halides. Now we are going to discuss, that is the 6th number reaction, that is the reaction with the air in presence of sunlight. So this reaction, that is a very important reaction with air in presence of sunlight. This reaction will be, suppose we are taking diethyl ether, we are taking and with the oxygen in presence of H nu, that is the sunlight, it will going to produce it will going to produce 1 ethoxy 1 ethoxy ethyl hydrogen peroxide, and when this product is being heated, furthermore it will going to explode, it will going to create lot of very serious explosion. So during the storage of the ether we have to take care of this point. If the ether is old one, then we have to check whether there is a presence of peroxide or not. If there is a presence of peroxide, it can be the source of a very severe explosion. So this reaction is very important. Seventh reaction that is going to discuss, that's halogenation reaction. Halogenation. When it is halogenated, then what going to happen? Let us understand. See, we have taken diethyl ether, and it is in presence of the sunlight, it has been halogenated and it is produced. First, this is the alpha hydrogen, here this first one alpha hydrogen will be eliminated, will be replaced by this chlorine. So it will first produce this CHCl OCH2CH3. This is the alpha chlorodiethyl ether. Next, when we again chlorinated it will going to produce the CHClO. Now this hydrogen atom will be replaced by this. This is alpha dash dichloroether, dichlorodiethyl ether. Now when this is in the excess chlorine, it is going to produce this CCl3 CCl2 the whole, and this is the perchlorodiethyl ether. So this is the halogenation reaction. Now we are going to discuss the electrophilic substitution reaction for the phenolic ether. Phenolic ether, there is a, when we incorporate this alkoxy group, suppose it is methoxy group, it is anisole. At that time, this is due to this fact that it will activate the benzene ring, and it is basically ortho and para directing. So when there is a nitration, concentrated HNO3 plus concentrated H2SO4, it is going to produce the mixture of the compound, that is orthonitro-anisole. This is anisole, orthonitro-anisole, and it will going to produce the para-nitro-anisole. This is para-nitro-anisole and it is orthonitro-anisole. First reaction, it is electrophilic substitution reaction of this phenolic ether. Second point, when it is halogenated, in this halogenation reaction we do not require any Lewis acid. And that is why, because this OCH3, that is this methoxy group, is going to activate the benzene ring. So we don't require any Lewis acid. So in ethanoic acid, bromine with ethanoic acid, it is going to produce a mixture of the product. This is orthobromoanisole, or this is an orthobromoanisole, and another product is parabromoanisole. Parabromoanisole. Okay, another product, another reaction that is given by, that is the Phenols reaction. Phenols reaction, this is in presence of aluminum chloride, this is Lewis acid, methyl chloride. It will going to be here, you will find the mixture of the product OCH3, the ortho position chlorine methyl group, and the para position also you can see the methyl group. Here this methyl group is the major product. It is called, it is 2-methoxy toluene. 2-methoxy toluene, and it is 4-methoxy toluene, and which is the major 4-methoxy toluene. Here also this will be the major and this will be the major. This is the Phenols reaction. Also you can incorporate the CH3CO group, acetyl group also in this benzene ring, and case of anisole. So this is the electrophilic substitution reactions. So that is all for the reaction that is been undergo by the ethers. That is, first we have discussed the very important thing, that is the reaction that is a Lewis base, the reaction that which acts as a Lewis base. Then we have discussed about the action with the halogen acid. Then we have discussed action with H2SO4, with the halogenations, and then we have discussed about different types of reactions, and lastly we have discussed about the electrophilic substitution reaction that is being undergo by the phenolic ethers, that is the anisole. We will find that is the physical reactions, nitration reactions, and other halogenation reactions. That is all for today's lecture, and this is the last lecture in this chapter. We have covered the parts of the syllabus, hopefully that will serve your purpose, and this is basically a service to the students who cannot afford the costly tuitions, because nowadays you can see there is a expenditure on the tuitions by different agencies that is very high. I think it will going to be helpful for those who cannot able to afford it. That is all for today's lecture. The next we will start the another chapter in this organic chemistry. Thank you very much for watching.